All right, so the first observation here is that we have these equal to signs, so that is a closed interval. And so as a closed interval, the first step is find critical numbers and then compare y values. So my first step here is going to be to notice that I have a variable divided by a variable. So I do need to use the quotient rule to find the derivative. Now, technically, when you're working with critical numbers, you think first about what is the domain of the function. In the last couple of examples, the domain has been all real numbers, so we haven't had to worry about it too much. Now, however, we have a denominator. And so what we would want to do at the beginning is to think about that domain and say that our denominator cannot be equal to 0. So that gives us x. Okay, now here's the thing. If you sit there and try to factor this x squared minus x plus 25, you would find that you can't factor it, right? So the plus 25 factors of 25 that add up to -1, that's just not going to happen for us, right? So what that would mean is that we would need to use the quadratic formula to try to identify what our solution would be to that equation. So in this case, I would plug in to my quadratic formula the a of 1, the b of -1, and the c of 25. So I would have -1 plus or minus -1 squared minus 4 times 1 times c of 25 over 2 times a. And what you're going to notice here is that you end up getting underneath this radical, you end up getting an imaginary number. Specifically, you end up getting -99 because you would have 1 minus the 4 times 25 would give you 100. So that's going to give you an I square root of 99. And because of that, what this means is that it's not real. And so we always ignore those imaginary numbers. And so because we always ignore the imaginary number, this domain restriction we're going to ignore, and we would say that there is no domain restriction. Now, again, if you skip this step, it's not going to be the end of the world, but technically that is what you would do, is you would identify the domain. And in this case, when I set that denominator equal to 0, I just get imaginary numbers. And because I always ignore imaginary numbers with functions, I would say that the domain is all real.